Please subscribe to the channel. Hit the like button and leave a comment. Thank you. Introduction. What is the prisoner hat riddle? Imagine 3 prisoners, let's call them Alice, Bob, and Charlie, who are captured and placed in a room. The jailer, who seems to enjoy mind games, tells them, "I will place a hat on each of your heads. Each hat is either red or blue. You cannot see your own hat, but you can see the hats of the other 2 prisoners. You must simultaneously guess the color of your own hat. If all 3 of you guess correctly, you will be set free. But if even one of you guesses wrong, all of you will be executed. Before I place the hats on your heads, you may discuss a strategy. Once the hats are on, no communication is allowed. The prisoners are left scratching their heads. How can they ensure that all 3 of them guess their hat colors correctly? The answer lies in a clever use of logic and teamwork. Let's break it down step by step. Step 1. Understanding the problem. Before jumping into the solution, let's make sure we fully understand the problem. Participants: 3 prisoners, Alice, Bob, and Charlie. Hats: each prisoner wears either a red or blue hat. There are 8 possible combinations of hat colors. 23(8). Rules: each prisoner can see the hats of the other 2, but not their own. All 3 must simultaneously guess their own hat color. If all 3 guesses are correct, they are free. If even one guess is wrong, all 3 are executed. They can discuss a strategy beforehand, but once the hats are on, no communication is allowed. The challenge is to devise a strategy that guarantees all 3 prisoners guess their hat colors correctly. Step 2. Exploring simple strategies. At first glance, the prisoners might consider some straightforward strategies. Let's explore a couple of them and see why they don't work. Strategy 1. Copy the majority. Each prisoner looks at the other 2 hats and guesses that their own hat matches the majority color. For example, if Alice sees Bob and Charlie both wearing red hats, she guesses her own hat is red. Problem: this strategy doesn't guarantee that all 3 guesses will be correct. If the actual hat distribution is 2 red and 1 blue, the prisoner with the blue hat will guess wrong. Strategy 2. All guess the same color. The prisoners agree that all 3 will guess the same color, say red. Problem: if the actual hat distribution is all blue, all 3 will guess wrong, leading to execution. These strategies fail because they don't account for all possible hat combinations. We need a more sophisticated approach. Step 3. Introducing parity, even-odd logic. The key to solving this riddle lies in using parity, a mathematical concept that deals with whether a number is even or odd. Here's how the prisoners can use parity to their advantage. Step 3.1. Assign numerical values to colors. The prisoners agree to assign numerical values to the hat colors. Red 1, blue 0. Step 3.2. Define the parity rule. The prisoners agree to use even parity. This means they will ensure that the total sum of all 3 hat values is even. For example, if the sum of the hat values is even E, G 0, 2, they will guess their own hat color to maintain even parity. If the sum is odd A, G 1, 3, they will guess their own hat color to make the sum even. Step 3.3. Applying the parity rule. Each prisoner calculates the sum of the 2 hats they can see. Based on the parity rule, they deduce their own hat color. Step 4. Walking through examples. Let's see how this strategy works in practice by examining specific examples. Example 1. Alice red, Bob blue, Charlie blue. Alice's perspective. Alice sees Bob blue 0 and Charlie blue 0. The sum of the visible hats is 0, 0, 0 even. To maintain even parity, Alice guesses her own hat is blue 0. Bob's perspective. Bob sees Alice red 1 and Charlie blue 0. The sum of the visible hats is 1, 0, 1 odd. To make the total sum even, Bob guesses his own hat is red 1. Charlie's perspective. Charlie sees Alice red 1 and Bob blue 0. The sum of the visible hats is 1, 0, 1 odd. To make the total sum even, Charlie guesses his own hat is red 1. In this case, Alice guesses wrong, while Bob and Charlie guess correctly. Since all 3 must guess correctly to be freed, this strategy fails in this scenario. Example 2. Alice red, Bob red, Charlie blue. Alice's perspective. Alice sees Bob red 1 and Charlie blue 0. The sum of the visible hats is 1, 0, 1 odd. To make the total sum even, Alice guesses her own hat is red 1. Bob's perspective. Bob sees Alice red 1 and Charlie blue 0. The sum of the visible hats is 101 odd. To make the total sum even, Bob guesses his own hat is red 1. Charlie's perspective. Charlie sees Alice red 1 and Bob red 1. The sum of the visible hats is 112 even. To maintain even parity, Charlie guesses his own hat is blue 0. In this case, all 3 prisoners guess correctly and are free. Step 5. Why does this strategy work? The brilliance of this strategy lies in its use of shared logic and consistency. Here's why it works. Shared rule. All prisoners follow the same parity rule, ensuring their guesses are consistent. Error alignment. If the initial sum of hat values is even, all prisoners will guess correctly. If it's odd, all will guess incorrectly. This alignment ensures that either all are correct or all are wrong. Guaranteed success. Since the prisoners can't control the actual hat distribution, this strategy maximizes their chances of success by aligning their guesses. Conclusion. The power of logical thinking. The prisoner hat riddle teaches us several valuable lessons. Logical reasoning. By using parity, the prisoners turn a seemingly impossible problem into a solvable one. Teamwork. The prisoners' ability to agree on a shared strategy is crucial to their success. Strategic planning. Thinking ahead and devising a plan can make the difference between success and failure. This riddle isn't just a fun brain teaser, it's a metaphor for how logical thinking and collaboration can help us overcome challenges in real life. So, the next time you face a tough problem, remember the prisoners and their clever use of parity. Please subscribe to the channel, hit the like button, and leave a comment. Thank you.